Alright, we shall continue with the next factor, effect of catalyst. A catalyst increases the rate of chemical reaction by providing an alternative pathway with lower activation energy. Activation energy is the minimum amount of energy required by a reactant molecules to initiate a chemical reaction. The presence of catalyst does not change the composition of the equilibrium mixture, affect the position of equilibrium, affect the value of equilibrium constant K. Time taken to achieve equilibrium will be shortened with the presence of catalyst. For example, we look at A plus B in equilibrium with C plus D. It's a homogeneous system since all the reactants and products are in gaseous phase. Now look at the potential energy in the absence of catalyst and in the presence of catalyst. It is very obvious for students to see the activation energy has been reduced in the presence of catalyst. This is what we mean by lower the activation energy. The next is effect of adding inert gases. At constant volume, total number of gaseous molecules increases. Total pressure increases of the equilibrium system increases. The volume and the quantity effect of adding inert gases at constant volume, the total number of gaseous molecules will increase. The total pressure of the equilibrium system also will increase. The volume and the quantity of the reacting species remain constant, so the partial pressure of each gases in the equilibrium system remains unchanged. That means there is no effect on the equilibrium position if you add inert gas at constant volume. Meanwhile, if you add inert gas at constant pressure, now what would happen? Adding inert gas to a system at constant external pressure increases volume of the container. When the volume is disturbed, partial pressure for the gases will be reduced or lowered. That means it will have the same effect as volume increases, volume increases, pressure decreases. So the position of equilibrium will shift in the direction to increase the number of moles because the reducing pressure due to the increasing volume is the external disturbance. So in order to increase the pressure back to re-establish the equilibrium, number of moles has to be increased. Consider the gas phase reaction CO plus O2 in equilibrium with CO2. Predict the equilibrium position when helium gas added to the equilibrium mixture at constant pressure and constant volume. Please take note, helium gas is an inert gas. Again, this question also, there is no solution here. So these two questions also students can ask during tutorial class. Please remind me, I will explain to you. Okay, applications of equilibrium principle in the Haber process to make an industrial process economically worthwhile. Nitrogen gas plus hydrogen gas to produce ammonia gas. 3 ways to maximize the yield or production of ammonia. First, you decrease the ammonia. Second, you decrease the volume or increase the pressure. Third, you decrease the temperature. By doing these 3 ways, you can increase the production of ammonia. That is based on Le Chatelier's principle. This is extra information for you. But the idea is here. When you decrease ammonia, what happens? The system will produce more in continual drive to reattain the equilibrium. Meaning to say, when we reduce the ammonia, equilibrium will shift forward or to the right. That means we will increase the production of ammonia. When we decrease the volume or we increase the pressure, what would happen? Our right-hand side of the equation has 2 mole, while our left-hand side of the equation has 4 mole. When you decrease the volume, the pressure will increase, so the system will move towards smaller number of moles. When it moves towards smaller number of moles, that means equilibrium will shift forward or to the right. In other words, it produces more ammonia if we shift to the right. Now look at decreasing the temperature, the third way. If you decrease the temperature, bear in mind, this is an exothermic reaction. If you decrease the temperature, that means system will release heat. When system release heat, equilibrium will shift forward and therefore more ammonia will be produced. At the same time, because it's moving forward, the value of Kc or Kp will increase. Okay, this is exercise for students to try. This will be similar to our tutorial book questions. So with that, we end chapter 6, but we need to do a lot of practice for chapter 6 because I skip all the calculation part because we need to do it hands on, not through video. Thank you.